Now we are going to start with the topic that is bases. Now as you are already familiar with the acid concept, so see how the bases are differentiated from acids. So according to Arrhenius, the bases were stated as, that means the substances when dissolved in water produce hydroxide ions is called as base. Suppose I have a beaker in which I have water, right? What I am doing, I am adding a certain substance to water. Suppose I am adding, you can say, the sodium hydroxide to water. Right. So when we just dissolve sodium hydroxide in water, so what happens? It gets dissociated to form Na positive and OH negative. So what does Arrhenius say actually? He says that any substance which when dissolved in water produce these ions, as you can see, hydroxide ions, they are called as bases. So according to Arrhenius, like if somebody is going to ask you about bases, you will state that according to Arrhenius, because see there are different concepts like the Lewis concept and the Bronsted-Lowry concept, and all these concepts you can say define bases in different terms. So at your level you need to know about the Arrhenius concept. So if somebody asks you about the bases, so just say that according to the Arrhenius theory, bases are bases are those substances which when dissolved in water produce hydroxide ion, that is the OH negative ion, right? Like in acid we did, the substances which when dissolved in water produce hydronium ion are called as acid. Likewise, the substances which when dissolved in water produce hydroxide ion are called as bases, right? So in both the cases we need to dissolve a substance in water. So keep in mind, according to Arrhenius, we can come to know about the nature of acid and base only when we dissolve that given substance, that is the acid or a base, in water. So the bases are you can say somehow the substances which when dissolved in water produce hydroxide ions. Now we are just looking for its preparation. Before we do preparation, I would just want to tell you one thing. See, some bases are soluble in water and some bases are insoluble in water, right? So the bases which are soluble in water are called by another term, that is the alkali. This I am telling you because see you come across different terms, you come across bases, you come across alkalis, so you should know what is the difference that exists between the base and an alkali. So that means all alkalis are bases only, right? So alkalis, or what are alkalis? Bases which are soluble in water are called as alkali, and the bases which are insoluble in water are called as bases only, right? So we can say alkali is a subclass of the bases, right? So all alkalis are bases, but all bases are not alkalis because they are not that means the all bases are not soluble in water, because we come across many bases which are insoluble, right? So the alkali, the alkaline term means one and the same, and that indicate those bases which are soluble in water. Now just look at the board how we can just prepare the bases. First method is by direct combination. That means we will be direct combining the you can say the substances which will give rise to the base. So just look at the board, what are those substances which are formed by the direct combination. Suppose we have Na and we just add oxygen to it. We know any substance when react with oxygen give rise to oxide. So obviously what is going to form? Oxide is going to form. And as you can see, it is a sodium oxide. So you should know that sodium oxide, and sodium is a metal. So we can say it is in general it is a metal oxide. All metal oxides except aluminium oxide and zinc oxides are basic in nature. So that means these are also bases, because when we will dissolve this kind of substance in water, it will just produce dissociate to produce the hydroxide ions. So that means the metal oxides are also regarded as the bases. So they can just be formed by reacting the metal with the oxygen. Another method, by reacting metal with water, right? By reacting metal with water. See, suppose I have a metal again, sodium, I am just reacting it with water. So we know when metal react with water, or any substance which react with water, it combines with the hydroxide ion. So this is what it is doing here. Na is combining with the hydroxide ions. So that leads to the formation of NaOH, and along with that hydrogen gas is produced. As you can see, it has the OH ion. So that means when dissolved in water, it will produce the hydroxide ion. That means it is also a base. See, in both cases what you have seen, in this example it contains the hydroxide ions. So by looking at it that it contains the hydroxide ion, it must be clear in your mind that yes, when dissolved in water, it is definitely it is going to produce the hydroxide ion. But in the first example, that is Na2O, because you don't get to see there is an oxide ion but there is no hydroxide ion. So that doesn't mean that it is not regarded as a base. So just keep in mind, see, when any substance dissolved in water produce hydroxide ion is called as base. Whether initially it contains the hydroxide ion or whether it doesn't contain the hydroxide ion, it is not you can say a definite criteria to act as a base. So as you can see, this is also basic in nature and this is also a strong base. So that indicates that OH is not a criteria, or you can say OH is not regarded as a definite group which must be present in a substance to just act as a base. So these are the two preparations. Third, we can just prepare it by reacting metal oxide with water. Right. So when we will react metal oxide, suppose again I am taking the sodium oxide, I am just reacting it with water, and we know that any substance which react with water just crisscross with the hydroxide ion. So it leads to the formation of NaOH, but no H2 is evolved. Just keep in mind, when you are reacting oxide with water, you do not get any kind of hydrogen gas, but when you react metal with water, you do get the hydrogen gas. So this is how that we can prepare the bases, right? Now we are just going to classify bases. As we just classified the acids, we are just going to classify the bases now, right? So just look at the board. So it's classification. So firstly, bases are classified on the properties, that is, suppose we say the strength of the base. So first classification we are doing on the basis of strength of base. When we talk of strength means the ability of a base to release the hydroxide ion when it is dissolved in water. Obviously the strength is this, right? So that means the ability of a base to release the hydroxide ion when it is dissolved in water. So on this basis, it is just divided into two categories. One is strong base, other is weak base. Right. So as we classified the acids on the basis of strength into strong acid and weak acid, likewise we just differentiate the base into strong base and weak base on the basis of strength. So the difference here lies is that strong acid was that which completely dissociates to produce the hydronium ion when dissolved in water. Similarly, it happens with the base, but the difference is that it produced the hydronium ion and it produced the hydroxide ion. So that means, suppose I am just differentiating the strong base with the weak base. So strong base is something which completely you can say completely dissociates, or you can say ionize, to give all its hydroxide ions. For example, if I have this hydroxide and if I say it acts as a strong base, that how I can show it? That means when it will get dissociated, it will fully get dissociated, producing the A positive and OH negative ion. That means in solution we are going to get, after dissolving AOH in water, we are going to get A positive and OH negative, and in the whole solution we won't be able to find this AOH molecule because it has been completely dissociated to produce A positive and hydroxide ion. So if this kind of thing you get to see in water, so that means the strength is too high and it acts as a strong base. And when we talk of weak base, so weak base is that which gets partially ionized. That means it do breaks, but it doesn't completely breaks. It just partially dissociate to produce hydroxide ion. Suppose again, I'm taking a general example. Suppose I have a base that is AOH. If I say that it acts as a weak base, then what is happening to it, or what kind of ions it is forming when it is dissolved in water? So what we are going to get? It will just dissociate to form A positive and hydroxide ion, and these ions are also have the ability to just unite and form the AOH molecule. So there is an equilibrium between the ions and the unionized molecule. So that means this is getting dissociated to form this, and at the same time they are also just combining with each other to form the unionized molecule. So that means in the solution we will get to see this, and moreover we will get to see this undissociated molecule as well. So that means it gets partially ionized, it doesn't get completely ionized, because if it has been completely ionized then we would have not seen this AOH molecule. But as I've told you, we are getting this AOH molecule also in water, so this indicates it partially ionized. So when any base when dissolved in water gets partially ionized, so that means it is a weak base, and if it gets completely ionized it acts as a strong base. So when we'll look for the examples, so suppose the alkali metal hydroxides, this NaOH, KOH, they are strong bases, and these ammonium hydroxide, calcium hydroxide, etc., they are regarded as a weak base. So keep in mind, all alkali metal hydroxides are regarded as a strong base, and when we talk about the alkaline earth metals, they are not so strong as compared to the alkali metal hydroxide. So this is how we are just going to classify the base on the basis of strength. Now we have a term that is the acidity. Like we had a term basicity for an acid, so likewise we have the term acidity for indicating the basic strength. So acidity of bases means the number of hydroxide ions produced when base is just added to water. So that means when we are adding base to water, so what number of hydroxide ion which we get to see is this indicates the acidity of the bases. See, basicity is for acids and acidity is for bases, right? So likewise in the acid one, in the basicity one, what you were doing, you were just indicating that number of hydronium ion produced when acid is just dissolved in water. Likewise we have the number of hydroxide ion produced when base is just added to water, and on the basis we just classify the bases into different categories. Like we have monoacidic base, we have diacidic base, we have triacidic base or polyacidic base, indicating the number of hydroxide ions produced when they are dissolved in water. So just do you have any example in your mind which indicates like in which the base carries only one hydroxide ion and that gets dissociated to produce that? Obviously, see, it is NaOH. So in NaOH, what you get to see that one sodium hydroxide molecule carry only one hydroxide ion. So that means when it will get dissociated, it will produce one hydroxide ion. So that means the base which when dissolved in water produce one hydroxide ion per molecule, that is called as the monoacidic base. And when we talk about the diacidic, that means we have to all the bases which carry two hydroxide ions in its one molecule, they are regarded as diacidic base. So just let's think of that which base can act as this. So yes, MgOH whole twice, because in one MgOH whole twice molecule, how many hydroxide ions do you get to see? 2, right? So that means when we are dissolving in water, we are going to get the 2 hydroxide ions. Just look at the board. It will be Mg2 positive and you will have 2OH negative. So these 2 hydroxide ion indicates the diacidic base. And when we talk about triacidic, suppose we have AlOH whole thrice. So see, you get to see that one molecule carries 3 hydroxide ions. So when it will get dissociated, it will form 3 hydroxide ion. So it is said to be the triacidic base. So likewise, depending upon the number of hydroxide ion they contain and the number of hydroxide ion that they will be just giving when they will be dissolved in water, they are called as the acidity of the bases, and accordingly we call that base as triacidic base, diacidic base or polyacidic base likewise, right? So this is somehow you can say the properties And moreover, like we had the acid on the basis of water content, we had the concentrated acid and a weak acid. Likewise, we have here the concentrated base and the weak base. So, you can say that a base which contain more amount of water is said to be a dilute base, and which contain the less amount of water is said to be concentrated base. Now, we will look for the physical properties. Now, as you are all familiar that what are bases actually according to Arrhenius, how they can be prepared, what are the classifications, on which properties you can just classify bases. Now, we are looking for the physical properties. Now, when we are talking about the physical properties, so first of all we should know that how we feel when we touch bases, right. So, you should know they are actually slippery in touch. So, that means bases are slippery in touch, right, and they give the feeling of, they have the, or you can say they give soapy feeling. So, they are soap-like, they are soap-like. So, they are slippery and they are actually soap-like. And when we talk about their ionization, so yes, they get ionized, and like the degree of ionization, like if it is true that when we pass electric current or whatever, when we add it to some other substance, they get ionized to the producing the ions, but though the degree of ionization is different for the different base according to its strength, that whether it is a strong base or it is a weak base, but they definitely get ionized, but the degree of dissociation is different for different base. Next property is solubility. See, most of the the hydroxides are not soluble in water, except the alkali metal hydroxides and the ammonium hydroxide. They are soluble. These are the exceptions which are soluble in water. Apart from these, that is the alkali metal hydroxide and the ammonium hydroxide, all other hydroxides are insoluble in water. So, I will just write an exception here, right. So, the exception is that alkali metal hydroxides and ammonium hydroxides are just soluble in water, all others are insoluble in water. Now, we will just see the action on the the indicators. So, when we talk of the indicators, suppose I am talking about the litmus, we are talking about the methyl orange, we are talking about the phenolphthalein. So, what is actually the action of base on these indicators? So, the bases actually turn red litmus blue, and when we were talking about the acids, what they were doing, they were just you can say changing the color of the blue litmus to red, but in case of base they are changing the red litmus to blue, and methyl orange, which is originally the orange in color, they are just changing into pink, the yellow color. And when we talk about phenolphthalein, they change phenolphthalein into pink. So, this is actually the effect of the base on the indicators, right. So, now as you are familiar with what are the bases actually, how they can be prepared, or how they are classified according to the strength and according to the number of hydroxides ion, that is the acidity of the bases, and you are almost familiar with the physical properties. So, I will just recall the physical properties again. They are slippery in touch, they are soap-like, they do ionization, or you can say they do ionize when they are dissolved in certain substance or when electric current is passed, but the degree of dissociation is different for the different base depending upon the strength. That is, for the strong base, the ionization is you can say the degree of ionization is high, and when we talk about the weak base, the degree of ionization is low, right. So, when we talk about the solubility, as I told you, see, the solubility factor is very important because it is actually linked with this alkali thing. As I told you, the bases which are soluble in water are called as alkali. So, that means, as I have told you, they are almost insoluble except the alkali metal hydroxide and the ammonium hydroxides, which are soluble in water. So, these are the one which are going to act as alkali actually. And when we talk of the indicators, so as you know that indicators are certain substances which bring about change in their color when we add certain substance to it, right. So, we have got a lot of indicators, we will take up a separate topic for that. for this instead I'm just using the normal indicators. So I'm just telling you the effect of base on these normal indicators. So on litmus what they are doing, they are turning red litmus blue. And what is their action on methyl orange, which is orange actually. So when they are treated with base, methyl orange turns yellow. And when we talk about phenolphthalein, which is originally colorless, so when we add base to it, its color changes to pink. Now we will be taking up the chemical